Hello everyone, and welcome to this week's Level Up Mathematics question. The question we will be looking at today is a trigonometry-based questions, which will cover concepts such as the sine law and other trigonometric ratios. So let's begin. The question reads, from the foot of a building, John has to look 22 degrees upwards to sight the top of a tree. From the top of a building, 150 meters above ground level, Emma has to look down at an angle of 50 degrees below the horizontal to sight the top of a tree. The question asks, how high is the tree? So essentially it's asking for this height right here. And so to solve that height, we can begin by solving this triangle right here. So for this, I'll redraw the triangle below. It looks something like this. Now, to solve the triangle means to find the angles on the inside, which is this, this, and this. Now, this angle right here in red, and the same with this angle, they're both 90-degree angles. So we know that they add up to 90 degrees. With that information, we can find this x and this x right here. This x is going to be 90 minus 22, which is 68 degrees, and this x is going to be 90 minus 50, which is 40 degrees. And so if I draw that in the new triangle, we have 68 degrees right here and 40 degrees right here. Now, with this information, we can find this last angle, theta. We know that all angles in a triangle add up to 180 degrees. And with that information, we can find theta. And so theta is going to be 180 minus 40 minus 68. And that gives us 72 degrees. And so it means that this right here is 72 degrees. Now, to find the height, we can begin by finding this length right here, and highlighted in red. And to do that, we will use sine law. So sine law states that sine A divided by A is equal to sine B divided by B. Let's say sine A is the 40-degree angle. So we'll say sine 40 divided by, and A is going to be opposite angle. But as you can see, the opposite angle to 40 degrees is what we're trying to find. So we'll leave that as A is equal to sine B. And we'll make sine B the 72-degree angle that we just found. And the opposite to that will be the 150 meter length divided by 150. And so with this information, we can solve for A. So sine 40 is 0.643 divided by A is equal to sine 72 divided by 150, which is 0.006. Now, with this information, we can solve for A by cross multiplying. So we're going to get 0.006A is equal to 0.643. To solve for A, we can divide both sides by 0.006. And then we will get A is equal to 101.4 meters. And so the length in red is 101.4 meters. Now, with this information, we can now solve for the height. And so I'll redraw the triangle as shown over here. So the triangle looks something like this. Here is the height of the tree. This is the length that we just found. And here is a 22-degree angle given. Now this is a right-angled triangle, meaning we could apply the trigonometric ratios. Well, one of the trigonometric ratios. And so let's look at which one we could apply. Here is a quick short form to know what each trigonometric ratio requires. It's SO, CA, TOA. So the O is for any opposite angles. The H is for any hypotenuses. And the A is for any adjacent angles. So let's look at what we have in our triangle. So to the 22-degree angle, we have an opposite, which is the height. So we now know that it has to be either the sine or the tangent. But opposite to the 90-degree angle, we have the 101.4 meter length. So we know that the trigonometric ratio has to be sine. So we'll say that sine 22 is equal to opposite, which is h, divided by hypotenuse, which is 101.4 meters. And this will give us a final height of 38.0 meters. And this is the answer to our question.